Welcome back to class 3 of thermodynamics. We're going to do some additional examples. These are going to come from Cengel, which is another thermodynamics textbook. It's a good one. I figured I'm using examples from our class example. I'm trying to remember the name of our book or the author, the principal author. I think it's Bornacki. Got his name spelled kind of funny. So anyway, here's an additional example, so we're not just relying on one source. And so we have this rigid tank. It contains 5 kilograms of a saturated liquid water at 90 degrees Celsius. Determine the pressure in the tank and the volume of the tank based on this information. Okay. Let's first off, I think we have to assume that it's saturated liquid. So saturated liquid, that generally means that we're on the line, and they've even shown us that they're on the line. I kind of that phrase saturated. I usually think of being a mixture, but I guess maybe technically, if you say it's a saturated liquid, it has to be on that line. If you say it's a saturated gas, it would be on this spot right here on the line, right? We usually use the saturated tables to find this out right here. So that's what was kind of bothering me. But I think this from the example was already gave you the answer, by the way. So let's pretend we don't have that. So we're going to write it out here and go to our steam tables. So that's going to be table for us, because they gave us the temperature. We're going to go, let's see, this is from the last example. We're going to go to Appendix B, and B.1.1 is the one where it has the index of it by the temperature. And they told us it was 7. Did they say, wait, is this US units? No, 90 degrees. I'm sorry, 90 degrees. So 90 degrees right here. Here's our information right there. And I guess we could go, right? I'm sorry. What happened there? Yeah. Here's the information we might want to have. I'm going to write this down. Table, good thing to write table. B.1.1 at T equals 90 degrees Celsius. We find out that the P sat is equal to 70.14 kilopascals. And we also have VF. Of course, we know all we need is the fluid, because they said it was a saturated liquid. So that's 0.001036, and this is cubic meters per kilogram. Right? We don't need the other ones. And so what we can find, I mean, sometimes you could, a simple thing like this, you can get messed up here. So let's we'll write out that we have the fluid is going to be the volume of the fluid divided by the mass of the fluid. They gave us the mass, and they want to know the volume of it. So first off, they asked it, determine the pressure in the tank. Well, that's this right there, right? You can see, like right over there, they said that's the pressure in the tank. Is it the same as the other? Did I write that wrong down? 0.18 thing is at 0.14. I might have left that at 8. Look it up again. So anyway, if we want to get the volume of this, all we need to do is multiply this by this, right? So it'd be easier. You could try to mix yourself up by accidentally dividing through by the thing. But if you write out this equation, then you'll know that you get it right. So 0.001036, and then multiply by 50, and we know that this was kilogram. This was cubic meters per kilogram, and this is a kilogram right there. So this is the volume of the fluid. We end up getting 0.05180 cubic meters. All right, so this is a pretty easy one. Let's do the next one's just as easy, really. It's pretty much just, this is a good exam question because if you don't know what you're doing, you wouldn't be able to do that like really quickly. But if you were just trying to memorize, they're going to ask a practical question from this. These are, okay, so Bornacki doesn't have them indexed, by the way, for English by pressure. So we actually had to do like sort of a little bit of an adjustment or a little quasi an approximation to be able to use Bernanke. So we'll see that here in a second. But here's our situation where we have 2 cubic feet of saturated water. So you can see already that means that's right onto there. And we want to take the vapor of saturated water vapor. Sorry, so that's why that's right there at 50 psi and determine the temperature and the mass of this right there, right? So they just changed the thing ever so slightly, but we need to look this up right here, and we need to go to the English units again. So that's going to be down here, and it's, I think, that's a bunch of stuff right there. There it is right there. Okay, so that's under 7, saturated water. But if you go, here's 7.1. Right, F.7.1, and you can see, okay, it's indexed by temperature. If you go down a couple, still by temperature. Now you get a superheated. See, they're missing the ones for by the pressure. That's okay. It's really just a convenience, to tell you the truth. You might have to do some interpolation if you're doing English units. So we said that we were going to have 50 psi. Well, that's going to be right here. And so that's really close. I mean, it's really, really close. So much so that you could just go say, hey, 49.189. I didn't even bother on my sheet here writing that down. Attempting to interpolate. Let's see, let me double check. This is the table F.7.1. And if we really cared, we could interpolate. P is equal to 49.189 psia. The temperature is 280 degrees Fahrenheit. And let's see, our VF. No, we don't need VF. We have a gas, so it's probably going to be this one. Let me double check it. Let's scroll up to the top. Yeah, VG is going to be VG is equal to 8.6498, and these are cubic feet per pound mass, right? Cubic feet per pound mass. So if you want to find out what the mass is going to be, like remember that we have VG equals VG over mg. We want to find the mass. We better find mg is equal to VG over V little vg, right? So they said that they had 2 cubic feet. Divide that by 8.6498, and you get that it's 0.2312 pounds mass. So that'll be the answer right there. This is the answer up here. And then here's the what they have noticing that this is saturated vapor, and then this is the value they got for the temperature. You can see that I'm off by 1 degree or 0.99 degrees. I think that's fair. We're going to do interpolation in a video coming up very soon, and then we're going to be doing it like probably over and over and over and over again until you hate interpolation. But don't worry, you'll survive. You'll get good at it, and then it won't be such a pain. I swear. See you next class.